My name is Dan Meyer. I'm Editor-in-Chief of RCR Wireless News. Joining me today will be an esteemed cast of characters who we'll talk with in a little bit to discuss the ever-evolving tower technology and network technology evolution that's going on right now in the industry. Obviously, there's a lot of push to next-generation networks out there, different efficiencies coming online to help out carriers, and so we'll be discussing that topic here today. As I mentioned, joining me today are some good characters here to provide some insight into this topic. I'll let them introduce themselves quickly before we move on. First of all, Ian Gillott from IGR. Ian, thanks for joining us today.
No problem. Thanks for being here.
Good deal. Can you give us, I guess, a quick intro of yourself and maybe IGR for those who might not know, those one or two people who might not know who you are out there?
So we are a market research company focused on wireless and mobile. So we spend our time looking at smartphones and tablets and LTE and small cells and DAS and all those good things. I've been around about 13 years, and I've been in the industry since, well, before you had grey hair, so what was that, 1992, right?
Yes, indeed.
5, right?
Yes, exactly. So, well, cool. All right, well, good deal. Well, thanks, Ian. Appreciate that. Also joining us today is Philip Sorrells, who's from CommScope. Philip, if you want to perhaps give a quick intro of yourself and also of CommScope, so people might get up to speed on you guys here really quick.
Sure. So my role at CommScope is strategic marketing. So I kind of oversee the analysis of what is happening in networks and what kind of solutions are needed, and help our team put together the right solutions at the right time. I represent the Andrew brand, so we're the inside CommScope. We have 3 key segments. The Andrew brand represents all things wireless. We have an enterprise division that looks at data center type applications, and a broadband segment that looks after cable TV and that type of broadband application.
Got it. And I think people who've been around the industry for a while are pretty familiar with the Andrew brand. I know you guys have been part of the industry for quite some time, so hopefully people are pretty familiar with you guys there. So, well, good deal, Phil. Appreciate it. And also joining us is Ken Sandfeld, who's joining us from Solid Technologies. Ken, if you want to do a quick intro as well, that'd be great.
Yes, good morning. Ken Sandfeld, VP of North American Sales. Solid is a manufacturer of DAS solutions, indoor, outdoor. We also make interference cancellation cell extenders, as well as front haul and back haul optical transport. Really focused mostly on the next generation networks as we move forward into small cells and other types of radio platforms that who knows what the future will bring. But we're a manufacturer of those type of topologies.
Perfect. That sounds great. Appreciate it. Thanks so much. So, well, great. Well, like I said, the topic we're going to be discussing today is kind of a free-form topic here, but kind of just discussing the new technologies coming out to help carriers as they move to LTE or different next-generation networks. So, to go along with this, us here at RCR, we recently released a report on the topic that you can get from our website at rcrwireless.com. And some of the insights we had from that report are just kind of looking at some of the issues with spectrum, which is obviously always a scarce resource for the industry. Carriers are spending lots of money on spectrum, trying to get as much use and efficiency as possible out of spectrum. And so I think a lot of the topic we're going to discuss today will be ways, I guess, to help carriers get the most that they can out of that spectrum resource, because obviously the government's trying to get more to market, but that's been a bit of a challenge. And so for carriers who are spending all this money on spectrum, trying to get as much as they can out of it is kind of the goal here. Another issue, or at least one of the solutions to help them out with that, is some new technologies happening at the cell sites, whether it's remote radio heads, smaller, lighter equipment, more advanced antenna technologies, use of fiber for backhaul, which is pretty important to make sure that the networks can handle the traffic that's coming online. Also, a lot of the older modes that were perhaps used in the past, like cell splitting, is still being used a lot by operators to enhance their coverage and capacity. Basically ways to kind of maybe double capacity in certain markets by just using more antennas or different cells to provide different capacity and coverage. And also look at small cells, which is becoming more and more important for carriers. It's still pretty small in deployment, but carriers are definitely looking at small cells as a way going forward to add more capacity in some of those higher density usage areas. So That's kind of what we looked at in our report. Again, you can check that out on our website, rcrwireless.com, and download that. But I want to bring on Ian maybe to give perhaps a high-level analyst and insight into maybe what he's seeing in the market, maybe some changes and challenges you've seen maybe in the market when it comes to carriers trying to enhance their network. So Ian, maybe a quick overview there for you would be good.
Okay, so see here. So I think the big thing, obviously, in the last few years has been LTE,
Okay.
and the move to that. I think the big change is that you know, rather than being seen as something they have to do as part of their next upgrade, it's rather something that they want to do, they the carriers, in order to get the higher capacity. Obviously, the speeds we're seeing are very significant. It is a big upgrade. I think people like the GSM operators, AT&T, T-Mobile, they kind of had to plan. They were able to plan this a little bit ahead of time. It's a little bit of a different migration for them compared to the CDMA operators. And certainly Sprint had more challenges because of its old IDEN network as well. So we've seen, it's kind of ironic that while we have everybody going to the same technology, the way they're getting there and the place they started from are all actually very different. And there really hasn't been one unifying path. I think the things we're finding with LTE are that certainly small cells become important because people, with a tablet, you're less likely to be running through the park, watching a video. Hopefully. Certainly not driving down the road. But whereas you used to, you'd have, people have traditionally moved through a network as they've consumed network capacity, making phone calls, etc. That's not necessarily the case now. We have a lot more people sit, browse, and view, which means that the capacity requirements at certain places increase. So that's where the small cell attractiveness, if you like, comes from.
Mm-hmm.
So, we could have put small cells in for 3G, right? But we really didn't have to that much. With LTE, that need is becoming much greater because you see these spikes in capacity at local areas. So I think the way we're deploying the networks now is different. It's changed because people's behavior is changing a little bit as well. Voice, obviously still very important, but my kids, they're loath to answer the phone. I can text them, and they'll certainly get on Facebook and browse and all those things. But and I'm not going to say voice usage is going to it's certainly flattened out. It may decline a little bit here, but certainly for a lot of people, it's still very important. The perceived value of it, though, I think is different, and that again changes how we build these networks. In terms of technologies, it seems to be that fiber to the cell site, you can't get it fiber to every cell site, obviously, and some of them it's just not economic. Here in Texas, I'm about to drive out through West Texas this afternoon for vacation. It doesn't make sense out there to put fiber to your cell sites. So there are going to be places where microwave still makes sense, but for the majority, if they can get fiber to them, they will. If you're going to be able to reuse your old fiber, and that's what we've really discussed in a new white paper we have on the website about front haul, back haul, and how the architectures of these networks is changing. So it's very expensive to build these networks, as we know. So anything you can redo, reuse, and the OPEX and CAPEX become absolutely critical. So yeah, that's a quick 5 minutes. There you go.
Yeah, that was good. Actually, very good topics. You're right. Like you said, the way the networks are being deployed now is much different than it was 10 years ago when it was all about making sure that people who are commuting home from work can make that call between the 5 and 6 time period, on the highway. Now it's about, kind of those usage spikes, like you said, in stationary areas as opposed to in the past. So
it's ironic if you think about it. My son just got his driver's license. I banned him, and actually in Texas, you are not allowed to have a cell phone turned on in the car for the first year you have your license. So we're actually telling people, don't make any phone calls through the network, right?
Yes.
Pull over at the side and do things. So actually, we're encouraging those spikes of increased usage at certain places.
Yeah.
What we really want from a network point of view is keep moving everything around, keep moving it through the network. We're telling people don't do that now. So,
Yeah.
Yeah.
It's definitely different now than it used to be. That's for sure. That's for sure. Well, good. Well, Philip, let's bring you on. Maybe get, I guess, some insight from yourself and from kind of CommScope's point of view and Andrew's point of view about kind of, I guess, where you see the market right now from a vendor's point of view on how carriers are evolving their networks and what you guys are kind of bringing to the table to help them with this evolution.
Right. Well, I would agree with everything that Ian said.
That's good.
Most of my insight into the market really comes from Ian, so I appreciate it.
I'm sorry to hear that.
We really see the market, our operator customers dealing with three big topics, and the big topics really are how do you modernize the network, right? So you have an existing 2G, an existing 3G. Now you're going to implement 4G. How do you do that modernization, and how do you do it in a way that doesn't break the bank?
Yeah.
And how do you do it in a way that doesn't disrupt the service that's already paying the bills for your company? So that's a big topic, and we're putting in a lot of our energy and initiative and solutions that help operators make that technology evolution in a smooth, simple, consistent, performance-assured way. The second big area is capacity efficiency. So you have an existing technology at an existing cell site, and you want to wring out every single dB out of that you possibly can get, so that you can avoid dealing with a small cell somewhere or some other ad. You want to maximize the capacity of what you've got. So we've got a suite of products that are aimed at that, including, as you mentioned earlier, Dan, techniques for splitting beams and splitting sectors and optimizing beams and optimizing sectors, and then a lot of things that are aimed at noise and interference reduction.
Mm-hmm.
You know, to me, a key thing about the difference between 4G and 2G and 3G is very simple. 2G was designed for voice. 3G was designed for voice with considerations for data, and 4G is designed for data. So in a 2G system, the key parameter was the signal strength. When you did a network plan, you were looking for signal strength intensity levels. And in an LTE network, the SNR is a more important parameter. You really want to minimize interference, so a really key difference there. And then the third big thing that our customers, operators around the world are really struggling with is managing the growth of OpEx relative to the amount of bandwidth that they are required to provide their operators. So you just can't have this continuing growth of OpEx growing at the same rate that your bandwidth consumption is growing. So there's got to be techniques, methodologies to implement the equipment and make the total cost of owning the network lower. And those are the areas that we're trying to attack with our outdoor equipment, with antennas and technologies in the antenna world, and with our DAS strategies, our backhaul strategies. That's the areas that the operator community tells us they need the most help, and that's where we're focusing our attention.
Got it. Makes sense. That sounds good. Well, good deal. Well, Ken, how about, I guess, maybe get some insight from you and from Solid Technologies and kind of how you guys view this evolution. Obviously, you guys do a lot with DAS and some small cells, non-traditional macro sites, things like that. What's, I guess, your view on kind of the challenges and what's kind of happening in the market right now?
Absolutely. Thank you, Dan. Well, one thing's for sure, your comment about the spectrum. You know, spectrum for the carriers is a blessing and a curse, right? It's a blessing because they get it. It's a curse because they got to do something with it. And doing something with it takes time and a lot of money and a lot of new technology. And so, to Ian's point, you got to do with what you have and grow it, right? I think there's one thing that's inevitable, no matter what, is the densification of the network, right? It's not just RSSI. It's just about getting that. It's physics, right? It's getting to the user. It's getting LTE. Like Philip said, is a new animal. It's all about getting those radios closer to the devices. We're really focused on the two areas that are most critical to that. In order to get that densification, you need to get that capacity to those points. So if you're going to do a 5-to-1 or a 10-to-1 densification or cell split, I guess is what we typically used to call it, right? A 10-to-1 cell split, you need to have a network that can drive that and support those points. The one thing that doesn't change is you still need to amplify those signals. That's where things really get different, because if we had a hard enough time getting the network we have in place now, can you imagine doing a 5 or a 10-to-1 split? a cell split in any given city. It's staggering. It's a staggering problem that the carriers are faced. And so we're really focused on things like size, noise. If you're going to do a massive densification of a network, size and heat and power consumption, all those things become a huge issue out in the field. And it doesn't matter whether it's a small cell, a radio head, or a DAS. All of those things are the same, right? In the end, you're still amplifying a signal and getting it out to the user. So we're very focused on those areas, to help the carriers kind of solve those problems. But one thing for sure, I think the reality is the brunt of that pain hasn't really been felt yet, because I don't think anyone's really rolled out a true densification plan yet for their networks. They just kind of status quo so far, So I guess we're kind of I think what we're seeing is they're encountering one little problem at a time, and then they're trying to find a solution for it, right? So what's happening now is we really need to help them tackle each of those and come to grips with the reality of how to solve those problems one by one, and they're pretty tough.
Yeah, no, yeah, definitely, that makes sense. It definitely seems like you said, they are kind of just going on a case-by-case basis when it seems, something pops up, they solve that, something else pops up, they solve that. They're not really going for that huge densification plan just yet. I mean, some of the carriers are looking at doing some stuff, but you're right, it hasn't really come to market.
Well, I think what we're seeing, and I think what you're going to see is you're going to see little pockets, right? They're going to pick some different types of the network, whether it's more rural, urban, or in the city, and they're going to say, okay, how are we going to solve it here? How are we going to solve it here? And how are we going to solve it here? To Ian's point, and I truly believe this, they're going to pull what's out of they're going to go to their toolkit. From vendors like Solid and CommScope, and they're going to say, what tools are you going to give me to solve my problem right here? Because it's different than the one down the street. And it's going to be quite interesting. I think what you're going to see is a big mix of solutions to solve those problems. And, obviously Solid is a proponent for fiber solutions, but whether it's backhaul or DAS. But regardless, the microwave, millimeter wave, all those different types of things are going to play into that toolkit as well, because there's going to be some places where you just can't go. Kind of like Ian's point, in the middle of, outside of Dallas, you're not going to get a fiber way out there.
Yeah, doesn't make any sense. Yeah, no, you're right. And I was talking with Verizon this week about that, and the kind of what they said was pretty much like you said, Ken. It's not one solution for every site. I mean, every site is a different problem. So they have to be able to have access to everything to on a case-by-case basis. So that seems to be a big challenge that they have to work through. Well, I guess
a key thing that we can do to help the operators with this is to help them find ways to go about a logical implementation. You can't eat the elephant all at one time. So a good idea, I think, is to really identify the hot sectors, the hottest sectors where you have the most valuable traffic, and come up with a workable, eat this elephant, move to the next one, build a scale, multiply that, and then work on standardization from there. So yeah, it's a little bit of a shotgun effect that's happening now, but I think that we're starting to see some of the major operators, some of the major players with LTE take a more precise type of approach that's really aimed at the hot sectors, aimed at the hot sites, aimed at the hot locations, and then building out from there.
Yeah.
And of course, the key to when that has to stop and when it really has to be transformational across the whole network is voice over LTE. Right? When you turn on voice over LTE, you have to have a pretty ubiquitous LTE system, or you're going to have a lot of disappointed customers. So that's a big challenge that's coming down the pike.
Yeah, that's probably maybe. I'm definitely going to have that question here at some point, because that does seem like to be perhaps an endpoint when it comes to these deployments. But maybe we'll talk. Maybe bring Ian back on here for a second to kind of, I guess, get your insight. I know you talk to carriers all the time about kind of where they are along these solutions. I mean, does it seem like to you that carriers are receptive? I mean, obviously, a lot of them are kind of stuck in their old ways, but are carriers becoming more receptive to using these new technologies to enhance their networks, or are you still finding perhaps some resistance to getting too advanced out there?
No, I mean, what we're seeing is a lot more of a mix. And actually, how I would characterize it is, and I realize I've got two vendors on the line, is there's much less of a reliance in saying, okay, I'm going to go to vendor A, B, and C and let them deal with it, right? So I think one of the big differences between 3G and 4G in my mind is that 3G was the big infrastructure vendors coming to the carriers saying, here's what I'm going to sell you next. LTE is the carriers saying, here's what I want, go build it for me. And so it's not just a case of, hey, you need to put in small cells, you need to put in remote radio heads or because metros, whatever it is, because that's how we do it now. It's more a case of, okay, I've got this problem, what do I do to solve it? So I think one example of this is the willingness to put in Wi-Fi hotspots, right? I mean, 5 years ago, no carrier on Earth would touch Wi-Fi hotspots. Now, it's an accepted part of the toolkit and the HetNet and all those things. And even partnering with a Boingo or a Time Warner Cable who's building out their own hotspots and then giving access to the carrier. So I think there's much more willingness to try different things because, you know, the traditional architectures of, I won't say they've reached the end of the line, but there's only so much we can do. We've got to get a little bit more creative. So.
Yeah, that's a good point. Good point there. I don't know, Ken, if you got any insight, maybe you're seeing more willingness from carriers. Like Ian said, you know, 4G is definitely a whole different model for these carriers. Are you seeing that they are a little more willing to maybe move on to different technologies there?
Well, I think where, you know, I think if you look at what it's rooted in is sure, it's performance and RF and capacity, but ultimately what they're looking for is lower cost solutions, right? You know, okay, so we've been doing it this way forever, right? But now guess what? We can't do it this way forever, right? We can't build a $250,000 cell site again. We need a, you know, I'll just say it, maybe like a $20,000 cell site, you know. And those require some massive changes both on the vendors as well as the carriers, right? Because they're going to have to potentially sacrifice something. Like they may have to go from, well, we don't need 3 sectors, we'll just use an omni. Maybe we won't use, maybe we won't blast into buildings with 40 watts. Maybe we'll live with 20 or 10 or 5 on a city street. And guess what? That will be great because we have, let's say we get 1,000 foot of line of sight. So I think they're learning where they're going to sacrifice and where their ideals are going to change so that they can adapt to growing this network because they know how to do it the way they've been doing it. And so we're all learning together. I mean, 4G, guys, we're only a couple years into it, right? We're still learning, all the issues. I can tell you in South Korea, where we've deployed over 200,000 radio head nodes on our networks, they're learning a lot about things like latencies, delays, issues with putting that densification in. I mean, software is one of the biggest issues. You can make the greatest amplifiers, the nice poles, nice fiber, nice everything, but if the stuff doesn't talk well together, software is becoming the biggest limiting factor. And compatibility or interoperability, I guess, is probably the proper word. Interoperability with existing systems, and how do you move forward without everything else being, not connecting? So those are some of the things we're seeing, and how to solve those. It's really going to be a lot of there's a lot of smaller companies coming out of the woodworks that are able to solve that capital, cost delta, and those software problems. Once you're a software solution, it's amazing the type of companies that are coming up in the market. It's quite interesting.
Yeah, makes sense. That sounds good. Well, Philip, maybe some view from you on that, and then unless Ian has a comment, maybe perhaps Ian's got a comment on that one.
I was just going to say to Ken's point, this is why they call LTE long-term employment, right? We're 2 years into this, and we've already got a load of issues to solve. It's going to be great when we get to release 10, 11, 12, 13. Vaulting.
Yeah, that's true. Oh, yeah, it does seem like we have CDMA and GSM pretty much mastered, but LTE is a whole new can of worms, that's for sure. So maybe
our focus at Andrew is really the RF part. So Ken and Ian may be right about the software and the software complexities, but our focus is RF. And I agree that we still have a lot of things to learn about what will really make a LTE system really sing, but for sure, we all know that LTE is an interference-limited system. And it's starting to become very clear in the implementations that we're seeing around the world that the more sector overlaps you have, really are detrimental to the overall performance of the system. So one of the key things that we're working on is helping operators sculpt the sectors, really using better antenna technology, take noise out of the system by making sure that you've got the right kind of connections done so you don't generate PIM products, providing operators with some consulting on how to lay out the plumbing of different cell sites so that you have the right frequency combinations that don't generate intermod products on each other. Those things all get very, very complicated. And then you add into it the mix of different frequency bands, which says you're going to have different size of equipment and different intermod mixes. Just the RF part of it is complicated enough for LTE as well. It's quite a complicated challenge to balance how you optimize LTE on a site where you also are launching 2G and 3G.
Yeah.
Quite a challenge.
Yeah, makes sense. Makes sense. Well, that brings up a good point too. I mean, it does seem like unlike CDMA and GSM to an extent, or 2G and 3G technologies, with LTE, spectrum is becoming a huge issue in the fact that carriers are trying to scrounge up spectrum wherever they can find it. So it seems like they're coming to the market with instead of just 1 or 2 bands that they're trying to have supported, they're trying to they're bringing 3 or 4 or 5 different bands that have to be supported by these networks. Maybe for Ian, I guess what kind of challenge do you see with just this diverse spectrum having to be used? The challenge there seems to be a pretty big challenge, but something that carriers can't get away from because there's no huge spectrum bands and single bands that they can get to anymore. They have to piece these things together to make these work.
Yeah, it's a jigsaw puzzle.
Yeah.
Where you don't know how many pieces you're going to need and what shape the pieces are. So.
Yeah.
But no, it is a problem because if you go, just look at the US alone. We've had the 850, 800 megahertz bands. We added 700, and Philip and I have spoken about this before. Is the antennas aren't too far apart for those bands, right? Now you jump up to the PCS band, which we've had for some time. You add on AWS. Now you jump up into the Clearwire bands, 2.5 gig. There's the WCS. What's that? 2.1, I think.
2.3. Yeah.
2.3. So, and now we're talking about other bands to go with this as well. You throw in what Dish was talking about and things like this. So it's great to take all this spectrum and glue it together, and things like LTE Advanced get a lot of attention because of that, because you can take disparate parts of spectrum and glue it into one effective LTE band. But spectrum propagates at different rates, different distances depending on the frequencies. So you have to compare it. And then you've got I think the biggest issue actually is the antenna issue. We talk about, I'll give you one example, small cells. We talk about deploying 40,000 small cells. Okay? Well, they're going to have antennas with them and radios and the baseband in there. And let's assume that's all upgradable. But let's suppose that the carrier that does that in a year's time gets some new spectrum that's not compatible with that antenna, which is a physical limitation. Are you going to go visit 40,000 locations again to do an upgrade? That could kill the cost model instantly for a small cell. So it's attractive to get all this spectrum, but the amount of planning and foresight you have to do, unless you have a really flexible and I'd say accessible, it's a huge problem. Physics is a bitchy. You can't get away from it in some respects.
Yeah, that's a good point. Well, maybe Ken. Obviously, Ken, you guys do a lot of work with smaller cells and DAS, and obviously spectrum is a huge issue with that too. What do you see in the market when it comes to being able to tile that spectrum together?
It's a nightmare. Antenna is a huge part of it. If we could have software to find antennas, that would be great.
Get on that, Philip. Get on that.
To Philip's point, you need an amplifier, you need RF to make the thing work eventually, right? You can go digital and all kinds of cool stuff out to a point, and then you have to get back to RF. And it's not getting any easier. A lot of the deployments we've done in Asia, I can tell you that if they add another band right now, they'd have to almost start over. It's that crazy, right? Now the transport network and the front haul and everything you can add, whether it's Ethernet or CPRI, that portion of the network is fully scalable and ready to go for the next 20 plus years. But the from the pole out is where it gets very painful, because we haven't overcome a lot of the physics in the industry yet. You still have to put amps and filters and all types of gizmos in there to make that whole thing work, right? And it takes up a lot of space. And most importantly, now I guess on the good side, it's typically protocol independent, but from a band perspective, it's not, right? So you either have to leave some space or do something, or maybe we'll have to see how that kind of shakes out. But right now, there's really no really good answer. Whether it's small cell, DAS, or Radiohead, it's a painful situation to add that spectrum. And then if you go into a TDD technology, it becomes even more of an issue, because now you have to do timing and synchronization, the receive and transmits, and it gets even more complicated. We deployed a TDD solution in Korea, and it works well. However, don't
touch it. Leave it alone.
Don't mess with it. I guess that's kind of long term. I think where you're going to see the most changes is really in the city networks, and in complementing that is in the in-building networks, right? Because that's where you can change things a little easier. You're going to a 15-foot pole instead of a 35 or a 55-foot pole. You're going inside a building and going onto a ceiling instead of up on a huge pole. So I think you're going to see a lot of advancements in those solutions to capture the bulk of the traffic from the users. Kind of like Ian was saying, you can't drive with the car, so you got to stop the car. So if the car is stopped on the side of the road, well, what's going to cover that? And let's say you're in a city. It can't be a pole down the road. It's going to be a pole real close to you. And that's really, I think, where a lot of the advancements are going to be made, is serving that density of the population inside and on the city streets. And I don't think the technology that's 30 miles outside of a city is necessarily where the technology is going to be rolled. Certainly you're going to put LTE out there, but are you going to be that concerned about interference out there? Not so much.
Yeah, that makes sense. Well, maybe Philip, I know obviously you guys do a lot of RF there. Maybe get your views on kind of bringing all that spectrum together and making a coherent network.
Well, certainly what we're trying to do is develop the right kind of antenna technologies and the right types of implementation of antenna systems to make that as easy as possible. So, for example, one of our newest innovations is what we call an ultra band antenna system that covers 700 megahertz all the way up to 960 megahertz, and then covers 1710 all the way up to 2.6 gigahertz. So there's still other frequencies that could come in and be required, but those are really aimed at covering as much as physically possible, given the laws of physics today, to be able to do, and then having multiple ports, all of whom have independent optimization. So you can optimize your LTE service, you can optimize your 3G service, you keep your 2G service the way it was in 1995 when you installed it the first time. So that's a key part of what we're doing. And then in the area of DAS ourselves, our focus is how do you, in a high venue, high traffic area where you have a multi-user hosted network, and you're going to have to add more nodes. It. So far in every LTE implementation that we've seen, the initial cut at how much capacity to add has been off the mark. Because once the user community starts using LTE handsets, they're not going back. They're going more. Yeah. So you have to add more nodes. So in a DAS system, the question is how scalable and how maintainable and how easy is it to implement, operate, and maintain becomes a critical issue. Because you may have hundreds of nodes, where in 2G you may have had tens of nodes. So you just have this scaling issue that has to be managed, so you have to have the appropriate kinds of system integration that allows you to do really elegant node management.
Yeah. Well, it seems like, like you said, being able to have an antenna, even just something simple like that can handle different spectrum bands, seems like a nice step at least to making that easier, at least for long-term planning when it comes to carriers bringing on different spectrum bands. So that at least a step in the right direction. But Well, I mean, obviously, you guys kind of brought up the issue of, just the small cells, and obviously that's becoming very important to this. I know, Ian, you've done a lot of research on small cells. I mean, are carriers planning far enough ahead for this that they can implement and integrate small cells into their current deployments without having to redo the whole system again? Because when you bring in small cells, you might have some interference issues with current networks. So you have to make sure you're planning ahead on these things to make sure you're doing this stuff right, and not have to redo things.
Yeah, I think they do. I mean, actually, what I'd say the carriers are not doing is going, "Oh, quick, small cells, put in 5 next week." It's being much more methodical than that, and I think there's quite a few vendors actually who would be quite happy if they said, "Quick, put in 5 small cells next week." I think there's a lot of people thought this industry is going to adopt small cells much faster than it actually will. It's going to be a slow growth, and the reason is it's they're tough to deploy. I mean, we all joke about how it takes 2 or 3 years to get permission to put up a new tower. Again, you said $250,000, right? That's great. Now go try and put poles down the street in my neighborhood. Yeah, good luck with that. It's probably harder, if not as hard. So I think those things come into it as well. The other thing as well is, of course, depends on what you define as small cell, but things like remote radio head, where you take the radio, push it up the tower, or put it next to the antenna, wherever that is, and then move the baseband back into a central office or a data center. That's a big change. That's ripping apart the radio network, re-architecting it, and you're putting in CIPRI, and you're doing a lot of different things there. You're not going to do that just because it looks good. You're going to do that to save money, and it's going to cost you money to do it. So more than likely, you're actually going to do that when you do a major upgrade to LTE, for example. So upgrading a 3G network to remote radio head, why would you do that? Right? Maybe there's some specific reason in a market that you have to do it, but in reality, why are you going to do it? What you're going to do is you're going to say, hey, we're going to LTE in 18 months' time. When we get that new spectrum, we've got our funding, at that time, I will deploy this architecture. And it will incorporate macro cells, small cells, et cetera, et cetera. Because these are massive. It's like ripping out the chassis, the gearbox, and the engine from your car and putting in a whole new one. You don't do that just for fun. You do it to get better mileage, or in my case, to get faster down the road.
Good point.
We know you're a power speed.
Yes, exactly. Well, yeah, I guess maybe from Ken, I guess maybe your thoughts on, our carriers. I mean, like the Korea deployment you guys talked about. Like you said, it was kind of something that is a tricky deployment, and hopefully that the carriers, don't have to mess with it too soon. But when it comes to small cells, I mean, are carriers planning far enough ahead with these deployments to be able to integrate new technologies and spectrum as they come online? Do you think?
Small cell right now, I would say is on the bleeding edge. Radio heads has been in the coming up for years now, and being optimized and smaller and more efficient and more reliable. It's been many years in the coming, right? Even before LTE was even around, when 3G was ready to be deployed, it was already a concept, right?
Yeah.
Small cells is definitely on the bleeding edge. I think the silicon, everything that goes with it and around it has been on the bleeding edge, and I think it's going to move fast. I think it's going to start moving fast in the next few years. The technology is very inexpensive, and there's a lot of new entrants that can come into the market with that technology. In my opinion, it's software limited more than anything. We talk about the interoperability between the network and these small cells. I believe that the small cells are going to come in pockets. The carriers are going to experiment with them. I mean, they're already connecting them to DAS systems, both radio heads and small cells, to say, hey, what if we use this to drive a DAS, And it's totally doable, and it works great, especially if you have an island of coverage, right? That's isolated from the noise from the network, That's where we see a lot of potential. I believe that Ethernet-fed small cells, as the silicon and the whole ecosystem that goes into that gets cheaper, you're going to see it. You're going to see it in more places. You're going to see it more in in-building applications. You're going to see it on low poles. I kind of equate it with, way back when, and probably still even today, when the European market was deploying very small little GSM radios, and you could go into a hotel and you would see basically a DSL backhaul little GSM radio. And the carrier would just plug one in there, and they say, oh, yeah, there's lots of parties here. We need to cover these people, right? Well, of course, now they're in trouble because you can't backhaul it with that anymore. And everyone's going to have to throw those in the garbage as the GSM network gets turned off. But the concept is the same. Oh, I got a problem here. Let's stick something in and let's make it work. It's kind of like Wi-Fi hotspot type of mentality.
Sure.
And I think as the software matures and the bleeding edge technology becomes more commonplace, I believe that you're going to see it being deployed on bigger scales, and I really think that's how it's going to happen. And it will be indoor and outdoor long term. It's just I think it's going to be kind of a combo until then.
Got it. I don't know, Phil, if you have any insight maybe you want to provide also. Obviously, you guys do a lot more maybe with the more traditional sites than small cells, but what's I guess the view from CommScope on kind of how the integration of small cells and how carriers are planning for kind of these futures with their current network deployments?
Right. So my view is that we really kind of do the industry and the operator community a little disservice when we use the term small cell as the definition of the solution instead of talking about small cell as the definition of the problem. So I think it's important for us in the supplier community to really make sure that we're clear that the small cell is a problem. It's not a solution. It's not the answer to small cell is not necessarily a radio technology. It's how do you put in the coverage and capacity in that hard-to-cover, tight, densified sector? That's really the problem at hand. And there's a whole multitude of ways to approach that. One way is to take your existing macros and make them more efficient. You use that macro cell site to split the sector, make a 5-time sector split, and use that to direct that energy into that spot that needs it the most. That's one way. Another way is to use a smaller radio head. Another way is to use a Pico. Another way is to use a DAS system approach attached to a radio head. The point is, small cells, it should define the problem. It shouldn't define the solution. And I see a lot of times we talk about small cells, we're really talking about Pico and Pico radios or femtos and femto radios. And I just think we need to help clarify the approach or clarify the definition of the problem and then bring to bear a lot of different solutions. Because going back to what Ken said earlier, it's going to be an many solutions to solve a lot of different problems. And there's going to be some time until we really find the right strategies that fit even the right markets at the right time. So there's a lot of tools that can be brought to bear here.
Yeah, definitely.
Our approach is to develop a radio-independent approach. So if the radio technology is a Pico, we want to help our customers solve where do you find the site, how do you get backhaul to it, how do you get power to it, and how do you optimize the performance. So whatever the radio technology is, we're going to try to bring ways to deliver the RF that goes with the radio.
Got it. Makes sense. Okay. Well, maybe as maybe like a wrap-up question for this, obviously we kind of got brought up earlier, but with VoLTE as being, maybe the endpoint of LTE deployments. Obviously, at some point, carriers are going to want to turn off their 2G and 3G networks. We use that spectrum for LTE or whatever comes after LTE. But to do that, obviously, 2G and 3G right now is supporting all the voice traffic, which is still important. VoLTE will be the answer to that at some point. And it seems like being able to support VoLTE is perhaps the biggest technology challenge out there, because there is a lot going on to making voice traffic over a data network work correctly for consumers at a quality of service level that's good for consumers, but also is being able to go between different bands and handoffs and stuff like that too. I mean, there's a lot going on there. So I don't know, maybe Ian, if your general view, maybe a wrap up of kind of how close are we to allowing carriers to turn off 2G and 3G to support only LTE, 4G from a technology perspective, and how important will that be for carriers when they can actually be able to do that?
So see, that's VoLTE for you. I'm gonna do that for you. Come on.
That's fantastic, man. That was really good.
So that's the problem, right?
Yes, no, exactly. You're right.
That's the problem.
That's the problem. So the problem is all about quality. We know we can deliver it, but can you do it to a level where my wife doesn't notice? My kids won't notice because they don't use voice. But really, can we have this type of conversation on a VoLTE connection reliably wherever we are? That's the challenge. I think the answer about when people will move, or the carriers will move away from the 2G and 3G networks is, I think, faster than a lot of people realize. But it's going to depend on who you are, because if you're a CDMA operator, the fallback, circuit switch fallback is a little bit more problematic. If you're a GSM guy, it seems to work pretty well. So for a GSM operator, UMTS operator, I can see them having VoLTE and a core, but falling back to circuit switch fallback more regularly. And so there's not that pressure to move onto an all LTE network. For the CDMA operators, it's going to be a little different. I think they'll do it faster than people realize. And I would not be surprised to see, I characterized this the other day for somebody, going all LTE on a network with VoLTE is like taking Starship Enterprise, pointing it towards the sun and hit warp drive, and hope you make it out the other side. And if you do, you're going to be sitting in a great shape, right? Your cost structure, your cost of operations, your flexibility, the services you can offer will be fantastic. But boy, it's got to work. So it's not the $1 billion question. It's the $50 billion question. It is a huge, but as I said, I think there's a lot of people pushing in that direction. It'll put competitive pressure on the other carriers if they can do it. But again, it comes back to that quality. We know we can deliver LTE, as Philip said, it's a data network. We can deliver that. I've got it today, and it's reliable and it works. I can get 15 megabits per second all over the place. But can I do it? That's the question.
Yeah, that's a challenge. Well, maybe, I don't know, Ken, and obviously people who might not know this, but Ken's been on this conversation using an LTE connection, which has been surprisingly working pretty well for us for this call. So definitely that seemed to work out okay. But definitely get Ken, I guess, your perspective.
His house looked like a hotel with all these decorations in the back.
We weren't going to talk about that, I thought. Come on.
It doesn't. I guess it doesn't help that I had to stick the modem on the actual piece of glass on the window over there.
Well, there you go.
Because there is no DAS in this building. I'll tell you that much.
Yeah. Well, and again, obviously, that makes it so. Obviously, DAS and small cells and RF. It's all going to be important for this VoLTE or this this evolution of the networks. From your point of view, Ken, how close are we to getting to that, and is that something that's in our future?
I agree with Ian. It depends on the operator. I think the CDMA guys are probably going to be pushing faster. A lot of it has to do, just like our lessons have learned from going from 2 to 3 to everything else. How fast can you get the guy out on the farm to switch from his flip phone to a new phone to a smartphone or whatever it is, right? Getting them to switch handsets is always the biggest challenge. I do think it's going to go faster than a switch from their older technologies, just because I think there's a lot to offer, and I think the carriers are going to have to kind of show that to the users. Look, we can save you money. It's this, it's that. In terms of deployment and kind of so I think it could happen as fast as 3 to 5 years. But I don't know. It could be delayed. It depends on the operator. It depends on how aggressive they want to go. But from a technology perspective, it comes down to what I said when we started the conversation, which is densification. It comes down to mitigating the noise issues, right, from that densification. And then I'll tell you what we've learned in Korea is you need an infrastructure for the backhaul, right? Latency is your biggest enemy. We know that from VoIP today, right? The latencies are your biggest enemy. It gets even worse with LTE Advanced. LTE Advanced requires that you actually have interoperable communications between nodes. So that means not only are you talking from handset to the node, you're talking between nodes. So you need capacity between the nodes. So the latency on the fiber network and the communications behind it are huge, huge, and I think that's going to be one of the biggest investments in addition to the RF component. It's going to be those two pieces to make it work. And if the carriers don't invest in that backhaul and front haul infrastructure, I think it's going to be I think there's no halfway. You can try. There's going to be a smorgasbord or a toolkit, as we like to call it now. There's going to be a toolkit of solutions, millimeter and LOS, and those are all going to be awesome. But in the end, the whole network can't be built on that because it's not going to be able to sustain things like VoLTE because the speeds are high and the latency issues are just tremendous. You know? So that's our take on it.
Yeah, good point. Good point. Philip, I want to give you maybe perhaps the last word on this topic here before we wrap up for the day.
Sure. I don't have quite the optimism that Kim has happen. The systems that I see today around the world are just too noisy. There's a lot of noise reduction that has to be dealt with, and it's not just the noise from the LTE system itself, it's the noise from everything else around it. That it's just going to take some more time than that. I do think the transition from 3G out, when operators might start considering turn off their 3G system, could happen faster. And my only reason for saying that is that I have young adults living in my house. And once they got their hands on 4G, you can bet that they're not going back to 3G. There's no question about that. So I think the transition from 3G out could happen faster than from 2G. I think 2G may be around for another 10 years just to handle that voice traffic.
Yeah, that's interesting. Yeah, I mean, I know Verizon's talking about launching VoLTE perhaps next year, but I took a recent road trip out to the far reaches of the western United States, and there was not a lot of LTE out there, I can tell you that. So there'll be some challenges getting that out there. So you know, I'm sure they've got the money and they've got the resources, but still, there's still a lot of work to be done. So well, I don't know if Ian, if you want to have a final word perhaps from you on this, or any final words from anybody at all before we wrap this up.
No, hey, I mean, in my mind, this is like 3G all over again, only better, because I think the issues now are bigger. I think VoLTE. Let me finish on VoLTE. I think putting in VoLTE will be pretty easy, relatively easy. It's voice over IP. It's not that hard. What's going to be really hard is the troubleshooting. So if I start going, then why did that happen? Is it Philip's interference? Is it Ken's front haul, back haul? Is it the device? Is it the software? Is it something completely different? I mean, who can diagnose that quickly and effectively and save the operator money? That's what it's going to be about, because there's so many moving parts to this thing. Today it's a circuit switch call. It's on dedicated spectrum, a dedicated channel, and it goes on a route we know about, and you can look at it, and it's very, very tolerable, right? I mean, the signal can degrade quite a way before you have problems, and we've trained everybody over the last 25 years to expect, you know, if you start dropping signal degrade, people say, yeah, just call me back.
Yeah.
And so we've trained people to do that, and I think that VoLTE is going to be a different animal with different interactions. And I said it's going to be who can diagnose the thing and get it, who can tune it, get it running, optimize it, because it's going to be all the problems all the way across the board. And we have zero experience about this. This is not Skype on a DSL connection. This is a wireless beast, and it's going to add a new dimension to it.
Yeah, that's a great point. Great point. Well, again, guys, we're just about out of time here. Obviously, this is a topic with so many different layers that we could talk about for hours on each one. Hopefully, we didn't short-shift this one a little too much, but again, I appreciate all the insights today from you guys, and some good insight there from the different perspectives there. So, again, guys, thanks so much for the time today. We appreciate it. Like I mentioned too, we have some more information on this from a report we just released on the rcrwireless.com website. You can check that out. Also, you can check out the website for Ian Gillott. Their IGR is at igr-inc.com, I believe. I got that right. Check that out.
White paper. Yeah,
there's a white paper there, exactly. And you can check out Ken at Solid Technologies. They've got some good information there. And also over at CommScope, Philip's company there, they have some good insight there too. So please feel free to check that out as well. So again, guys, thanks so much for the time today, and we appreciate it. And thanks everyone for joining us.
Thanks.
Thank you. Thanks for having me.
Thanks.